So after we understood what is one-hot encoding and response encoding, and we have also seen that how response encoding would make sense to this particular problem, where we will look at for a particular gene I, we will look at the probability that how it is occurring for that. So that is the value we're going to impute, and the advantage we have seen for response encoding is that it will create number of columns equivalent to total number of basically number of class outputs you have. So in this case it's going to be 9. Now we will see that how to perform these things in the practically in the Python notebook. So first thing is that we need to create a one hot encoder, and I will show you up that one hot encoder will create much more columns for gene in comparison to when we will go back to your basically response encoding part. So here we are going to take the help of count vectorizer, as you might already be aware of this, and we are going to pass my gene column in the fit transform, and this is going to convert it for my train, for test, and for cross validations. For all the three data sets we're going to do the same, and after we got it we can look for the train shape or test shape or Chevy shape, doesn't matter. But if you will look at it, you will notice that for the gene column it have created 227 columns, right? Which is huge. Just for one gene column we got 227, but it's okay. There are few algorithms like basically if you look at, let's say, linear logistic regressions, they perform really well if you have even huge dimensions. So we will see in those cases there will be no issue, but there will be few algorithms like KNN, where maybe, like for example, when I will say KNN, K nearest neighbor, then in that case maybe this may not work good, and we may want to move towards a smaller dimension data, which response encoding can help us do. So now let's go ahead and see a few more things to it. Now here you can see we can also look at all the column names that I have created. So we can just say get feature names, and it's going to return me all the column names which it is going to return. Now after that we're going to see how to perform a response encoding. Now for response encoding, what we are going to do, if you look at it again, we are passing this gene column, and here we are also going to use something called as Laplace smoothing. Now this is also one of the very interesting concept. In fact, this Laplace smoothing, I'm going to use this almost throughout this project, and even at a lot of places I'm going to use this calibrated classifier as well. So you should really know what is all this. If you don't know, don't worry, in the next lecture I will explain you what this Laplace smoothing is required, why Laplace smoothing is required, and basically what's the significance of this, why I'm basically using this into my project. Now in this case I have chosen the value alpha for performing Laplace smoothing, but right now don't worry about it. As I said, I'm going to explain you what is Laplace smoothing just in the next lecture. So for now just take it some value alpha, we are passing it on, and it's just getting it work. Now after that, what we are doing, we have created a function. Now what I have done for this function, this function is taking my input for Laplace smoothing, one something called as alpha, and it's taking the gene column which is there, and your training data set or testing data set or cross validation data set, and it's gonna return you the response encoding value for it. Now when this is gonna be returned, you can notice that when I looked at the shape of this, the output of this, you can notice that I got only 9 columns instead of 227 columns what we were getting in one hot encoder. That's basically is the beauty about this response encoding. Now for doing this, this function is not available to you by default. So for this I have written a Python code for it, and I would strongly recommend all of you to go through this particular code. This is a well commented code. You can see that each and every line is properly commented, so that you should not face any issue in understanding this particular concept. So it's very simple code. Just go through it line by line, and this is exactly the same thing what I explained you, that how we calculate the response encoding in terms of those probability terms. So please go through it line by line. It will really help you to understand. So this is one also an art you should learn. Though definitely you need not be a very good Python developer, but this is quite simple to get that. So I leave this as a homework for you to basically go through this particular functions and kind of work on that. And Laplace, let's get, I'm going to introduce this in the next lecture. This Laplace, what is collaborator classifier. So I'm going to talk about all this in the next lecture.